let's talk more about, linear regression, right? That has been a staple for, econometrics. It is a staple for us as well for, in market mix modeling, as you understand. It's an advanced form of linear regression, but still the foundations are linear regression. And when you talk about causal inference methods, we leverage a lot of, regressions. How important do you think, linear regression is when it comes to causal inference methods?
That's perfect. Uh, OLS is
Mhm.
basically the working horse for all way, especially us that like I call myself as an applied econometrician or applied microeconometrician.
Mhm.
And well, for us, it's really fine to use OLS. And it's not because OLS is the best tool, but it's because it's the best among the simplest tool, right?
Mhm.
Uh, One coefficient of the OLS would give me the interpretation that by how much Y increases, like sales increase, for instance, if I increase $1 spent on TikTok ads, all
Mhm.
else constant, like conditional
Mhm.
expectations. And this is great. This is what we need at the end of the day, right? If all assumptions are met that the features are exogenous and so on, those coefficients would be causal. The problem is that we don't meet the assumptions for causal inference only with OLS. So then we go to regression discontinuity design that exploits like small bandwidths in which people or subjects, whatever, are similar, and it fits an OLS to estimate the difference in outcome between those two groups. But regression discontinuity design uses OLS, like the two-way fixed effect approach that we used before and call it the difference in difference that changed a lot in the last decade was estimated via OLS. The two-stage least square with instrumental variables is like a tweak of using OLS. So it worked for us. It was simple enough for us to indoctrinate the students since their undergrad, but it does not do a good job in estimating heterogeneous effects, for example. Like you're not going to estimate 50 or 500 separate OLS regressions to get a sense of how different people react to a treatment. So now we are migrating to other methods of machine learning, like double machine learning or causal random forest that can give us a sense on heterogeneous treatment effects, and also they take care of things that OLS didn't take, that
Mhm.
are non-linear or complex relations between multiple variables. OLS doesn't do a good job unless you use a fully saturated model, which means like interacting all the regression, the variables and so on. So we are migrating for this, and people are giving fancy names such as causal AI, causal machine learning, but the thing is the same. You still need to meet the same hypothesis you needed for OLS, but now it's going to be a bit easier to meet those hypotheses. That's the same. It does not like, let's say that double machine learning and OLS are frameworks, but the identification methodologies, they are RDD, difference in differences, and so on, in which you can apply those frameworks. So you can run a different diff with OLS or with double machine learning. I don't know if you get this.
Understood.
So OLS works. It's simple. It's great. We are trying to move to something fancier, but don't let this fancier setup fool you. We still need to meet the requirements.
Yeah, so basically the foundations are still, the OLS and linear regression. OLS is a method to fit any linear regression method. Yeah, but yeah, so these spaces is needed. On top of that, as you rightly said, you can add, random causal forest. You can also add causal ML, and I think that is the, enhancement rather than a core component. Am I right on that?
Yeah, I think it's an enhancement. Moving from OLS to double machine learning when you need, when it's needed, when it makes sense, it's an enhancement. But again, you still need to meet a lot of requirements, most of them the same you needed to meet with OLS to achieve to a causal interpretation at the end of the day.
Great.